Hello again and welcome. Today we're going to take a second look at our simulated microwave oven capacitor discharge test. What we're going to do is take all the meters that had passed my original 5 kV testing using our transient generator in the back, and we're going to see if these will all survive discharging this microwave oven capacitor while the meters are in their resistance mode. So let's just go ahead and we'll get set up and we'll start running them. Here I have one of the Brymen BM869s. I had purchased this meter brand new back in 2015. While I did damage this meter during some transient testing, I did rebuild it using the OEM parts. So this meter is 100% functional. Now, I do have a second BM869s. It's the one in the back. Now this meter has been through a lot more testing than what my original one has been. This one's been exposed to a 50,000 cycle life test. I also transient tested this meter and damaged it, but I rebuilt it using different parts than what the OEM supplied. So this meter has actually been transient tested at 14,000 volts. One of the other things I did with this meter is I swapped out an IC that extends the backlight timer. Because this meter has been modified so extensively, I wouldn't run it across this test. Not that I'm concerned about a damage in the meter, I just don't think that we would learn anything from it. So we're going to be using this one, and you can tell that this is the original meter. It's marked a little bit differently than the newer one that I bought. This one came out of TME in Poland, I believe. You can see how the one that they sent me is marked. The other telltale is that I have these little plugs in the current inputs. So let's go ahead and we'll turn on our power supply and we'll let this capacitor bank charge up a little bit. Now again, this capacitor is 1 microfarad and we're going to charge it to 2000 volts. Yeah, this is not something that you want to touch on the two sides and take it across to your heart. So here we have it at 2000 volts. We'll go ahead and set the BM869s to resistance. And let's go ahead and discharge our bank. Let's take our probe and we'll measure the input shorted, and you can see the meter reads basically 0 ohms. Again, we'll let the capacitor bank charge back up, and here we're pretty close again to 2000 volts. Again, it is a 1000 to 1 ratio, and let's discharge it a second time. And again, we'll go ahead and try reading a short with this. And it looks like our BM869s survived that test just fine. And now what we can do is connect some other test leads to it. Let's just try reading a few different values. Here's 100 ohms. Here's a 10k ohm. Here's a 1 meg. And here is the 10 meg ohm resistor. So it doesn't appear that we've damaged the BM869s. One of the things I'd like to show you is that when I discharged the capacitor bank directly across the meter, it didn't make a big crack. Now that's because the impedance of the meter is actually quite high. It's about 1.2 k ohms or so. So that limits the current that's coming out of this capacitor. If we were to take the two leads and short those two together and now discharge the capacitor bank, this should make a little bit louder crack. I don't know, I probably saturated the microphone of the camera, but it is a lot louder. And again, that's because now we have a low impedance path instead of the meter's high impedance path. Now again, when I'm testing with our transient generator, I mentioned frequently that this has a 2 ohm source impedance, so that's what's limiting the current on this if the meter were to break over and short. This is a Brymen BM869. Now, a few things I want to mention. Brymen had supplied me with some of the early BM786s as well as a 789. As they were making changes to those meters, they were supplying me parts to upgrade the meters that I had. Eventually, I had changed out one of the ICs that would have hurt the calibration of the meter. So this is a brand new meter that I've never transient tested, but I did test the other ones and those all survived. So I have a lot of confidence that this meter will survive this particular test. So to be clear, this is basically a production meter. This isn't one of the early ones that we used during development. Again, we'll place it in resistance mode. And let's go ahead and discharge it. And let's try reading a short. See, it's working fine. Let's go ahead and let the capacitor bank recharge. And here we are at basically 2000 volts. And we'll give it a second discharge. And again, let's try reading a short. And you can see it reads 0 ohms. And we can go ahead and connect our other test leads real quick. Verify a few other resistance values with it. So again, here we are with a 100 ohm. And you can see it's reading basically spot on at 100. Here we are at 10. Here's 1 meg. And here we are at 10 meg. So our BM789 survived this test just fine. Alright, here we have the Brymen BM235. Again, we can go ahead and measure our short. And here it is with an open. Alright, we're right at 2000 volts. Let's give it our first discharge and let's just check it. See, it still reads a short, no problem. Again, I want to be very clear. I would never suggest that anyone discharges their microwave oven capacitors this way, but I just want to show you that a lot of these meters could actually survive this kind of a test. Alright, here you go, 2000 volts. See, it shorts out our bank just fine, and here it is, again reading a short. Here it is with a 100 ohm resistor. Here's a 10K resistor. Here's a 1 meg. And here is the 10 meg ohm. Takes a little bit to settle. There you go. So no damage to the BM235. Alright, so here we have the Brymen BM319s. This is their automotive meter. And you see it's placed in the resistance mode. It's currently reading an open. Here it is with a short. And you can see we're just now getting to 2000 volts. Let's go ahead and do our first discharge. And you can see still reads a dead short just fine. And here we are at 2000 volts. Let's give it our second discharge. And again, we'll go ahead and check it for a dead short. Seems to work fine. And here is a 100 ohm resistor and a 10K, a 1 meg, and our 10 meg ohm. So the BM319s survived that just fine. This meter is produced by Brymen for Amprobe. This is a model PM55A. I purchased this meter after somebody complained about the quality of these meters. They had bought several of them and they said that they basically all died. I don't remember when I purchased this meter, but I actually ran several battery discharge tests with it, and then I let it sit outside in the elements for I think close to a year, certainly over a winter. So then I finally gave up on that test, and here it is today. So it's set to the resistance mode right now. You can see if I read a short, it doesn't have any problem with that. Now this particular meter has the leads attached to it permanently. So you can see I have our little adapters out. And here we're at 2000 volts. We'll go ahead and do our first discharge. And let's try to read the resistance with a short. See, it picks that up with no problem. We'll let it charge up again. Here we are at 2000 volts. And let's try it again with a short. You can see no problems at all. So this will be a 100 ohm. This meter tops out at 600 ohms. Let's try it with a 1K ohm. Yeah, I can't read that. Here's a 50. Placing it here in resistance. I think it can read higher. Let's try 10K. Yep. Here's a 1 meg. Yep. Alright, what we're going to do is let's just discharge this through the meter a second time while we have it in this other mode. It's already charged up. You can see 2000 volts. There you go. And let's try it with our short. Alright, we're at 2000 volts, and here we go. There's the discharge, and again, here it is with a short. This will be a 100 ohm resistor, and here's our 10K, and here's our 1 meg. So yeah, no damage to the PM55A. Okay, here we have our little Fluke 101. Let's try it with a short. And you can see it's reading 0 ohms. Capacitor bank is already charged up. Let's go ahead and discharge it. There you go. And let's try reading our short. No problems at all. Again, this Fluke 101 has survived all the transients I've ever exposed it to. Alright, there's our 2000 volts. Let's go ahead and discharge it. And we'll check it again. See, it reads a short. Alright, let's just try it with our 100 ohm. And you can see it reads 100.4. Here's our 10k ohm. Reads 10.02k. Here it is with a 1 meg. It's reading 1.000. And here it is with a 10 meg ohm. And that's reading 10.03, 2, 1. Will it get down to 0? Nope, that's where it's going to settle off at. I don't know what this cost today, but back when I bought it, it was about $50. This is a very solid meter. Here we have the Fluke 115. This meter survived all my transient testing just fine. And you can see it's reading an open. And here it is with a short. We'll go ahead and charge up our capacitor bank. And there's our 2000 volts. Here's our first discharge. And let's go ahead and measure our short circuit. You can see it reads 0.1 ohms. And here's an open. Just let it charge up again. And here we are at 2000 again. And there's our discharge. And again, we'll measure the resistance with a short, and you can see it reads 0.1 ohms. Here we are with a 100 ohm. Here's a 10k ohm. Here's a 1 meg. And here's our 10 meg ohm. And you can see it reads it just fine, no problem. So no damage to the Fluke 115. Here we have the 17B Plus. I ran this meter through a 50,000 cycle life test on this switch. And this one by far performed the best out of all the meters I looked at. Alright, you can see I already have the capacitor bank all charged up. Let's go ahead and do our discharge. And let's try reading our short. See, it reads 0.6 ohms, 0.5 ohms. Just go ahead and let her charge back up. And there you go. Let's go ahead and discharge it a second time. See, it's discharged. And again, we'll try it with a short. And you can see it's reading 0.5 ohms. Let's just swap the leads out real quick. And again, here we are with a 100 ohm resistor. Here's our 10k. Here's our 1 meg. And here's our 10 meg ohm. So the Fluke 17B Plus survived that test just fine. And here we have the Fluke 87V. See, it's reading 0.1 ohms. And let's go ahead and discharge our bank. And again, we'll check it with a short. And again, we'll discharge our bank. And we'll check it again with a short. Again, here we are with a 100 ohm resistor. 100.2. Here it is with a 10k. 10.00. There's a 1 meg. And here it is with our 10 meg ohm. So no issues at all with the 87V. This is a Fluke 187. Now, I've never tested this meter on our low voltage transient generator, but I did run a thorough test on the Fluke 189, and that meter survived just fine on that transient generator. We're going to go ahead and run this meter. Again, this is a 100% functional, no problems at all. These are a very good meter. I've got a few of these. Let's go ahead and we'll turn on our power supply here. And here's 2000 volts. And we have it discharged. And let's try to read a short. You can see it's reading 0.08 ohms. Again, here we are, 2000 volts. There's our discharge. And again, we'll measure a short. And you can see no problems at all. Alright, let's just measure a couple other values. So here's 100 ohms. And here's a 10K ohm. Here's our 1 meg. And here's a 10 meg. So no problems with the 187. This is the Fluke 189 that I normally use. You can see I have the extended C battery pack attached to this. I'm using rechargeable batteries in this, and I have yet to have to pull those out and recharge them. Alright, there's 2000 volts. Let's go ahead and do our discharge. And let's try measuring a short. And you can see it's reading 0.08 ohms again. Again, we'll just let this charge up. Alright, and here we are, basically 2000 volts. And let's discharge it again. And let's try reading our dead short. No problems at all. And again, here's our 100 ohm resistor. See, it's 100.26. Here's our 10K. Here's the 1 meg. And here's the 10 meg. No problems at all. Here we have the Gossen Metrawatt MetraHit Ultra. They changed the brand of this meter since I tested it. It's now referred to as the Prime. Again, this meter had a lot of issues. They shipped it with no shielding on the inside, which really made this meter quite useless. Let's go ahead and turn it on. You can hear the little relay click. The battery's quite low. Could use to be charged. But you can see it's reading an open. You can see the leads are backwards on this meter, so the current is on the right. The main lead is on the left. I don't know why they flipped it like that, but there's a lot of things that are a little unusual about this meter. So here we are with our dead short. You can see it's reading 0.000 ohms. Let's go ahead and flip on our power supply. Electrically, this meter is actually very robust, and this is probably about the closest handheld meter I've got that'll compete with my bench meter. This thing has a resolution of 300,000 counts. Alright, let's go ahead and try it out. See, we have 2000 volts. Here we discharge the bank. And again, we'll go ahead and attach our short across the meter. And you can see it's reading 0.001 ohms. Let's go ahead and charge up the bank again. This meter is Bluetooth enabled. It's fairly easy to interface to it with LabVIEW. I gave a demonstration on that when I evaluated this meter. Alright, you can see we're at 2000 volts. And here we'll discharge it again. And let's go ahead and measure our short. No problems at all. This is our 100 ohm resistor. Here's our 10K ohm. Here's the 1 meg. And here's our 10 meg. So no damage to the Gossen. We have the Hioki DT4252. Again, a very robust meter, but I have not used this since I transient tested it. Looks like it's still okay with the batteries. This meter was never electrically damaged during my transient testing. It did arc around one of the connectors. I added a little piece of Teflon or something in there to increase the insulation of the meter, and then tested it at even higher voltages. Alright, let's go ahead and we'll short this out real quick. You can see it's reading 0.1 ohms. And here we go. So we discharge the bank. You can see it's reading 0 volts. And let's go ahead and read a short again. No problems at all. Again, here we are, 2000 volts. Again, we'll go ahead and discharge our bank. Again, see 0 volts here. And here it is with a short. You can see it's reading 0.2 ohms. And again, we'll go ahead and read a few values. So here we are at 100 ohms. You can see it's 100.6 or so. Here's our 10K ohm. 10.00. And here's the 1 meg. 10.001, and here it is with our 10 mega ohms. 10.10. No problems at all with the Hioki. Here we have the Keysight U1282A. This is not a very electrically robust meter for the cost. And you can see it is functional. Here it is with the short. Now I damaged this meter with my transient testing, and I went ahead and ran a 50,000 life cycle on the switch. Ended up breaking some of the plastic. I found a donor meter eventually that I used to rebuild it. So it is 100% functional again. You can hear the switch is still a little mushy, but electrically it's in good shape now. Now would this meter survive this testing? We're not even going to attempt it because I'm not confident enough that I wouldn't damage it. Here's another fairly expensive meter. This is made by Uni-T. This is the 181A. Again, this is a Fluke 289 knockoff, essentially, except it has a color display and a rechargeable battery. I don't know if this will even turn on. It's been quite a long time since I've used it. Yeah, you can see the battery's totally dead, and this thing takes about 12 hours at least to charge up. So right now you can't even use the meter. This is what I don't like about these rechargeable cells is you go to use them and the battery's dead. You can't just plug in new batteries again to get it running. Now, I have a lot of confidence that this meter would survive this testing, but this meter has been modified. If you watch the review where I tested this meter, this was taken out with a grill starter at 1 pulse. I had to change out, I think, one of the power supply controller chips, but then I ended up chopping up the circuit board to try to address the main issue with this. And I don't know if Uni-T has ever gone back and revised this meter to improve its robustness. If you own one of these, this is not a test I would run on it. This is Dave's 121GW. Now, I purchased 2 of these. This is production number 2. This is the meter that I exposed to my transient testing, and I also ran the life cycle test on, so you can hear how spongy this switch is. Now, this meter is not 100% functional right now. You can see it is reading an open in ohms mode. I'm not sure if this thing can actually read a shorted resistor or not. Let's just try it real quick. Here it is with a dead short. And you can see it's reading 0.008 ohms or so. Let's just try reading a few different values with this real quick. If it is kind of functional, we can go ahead and run this test. So here it is with a 100 ohm resistor. And you can see it's reading 100.21. Here's a 10k ohm. Pretty much spot on. And here it is with a 1 meg. A little bit of leaking. I think that's what happened the first time when I hit this with the grill starter. It started leaking a little bit. So you can see the resistance is off just slightly. But it's good enough. I think we can run this test on it. So let's go ahead and we'll turn on the power supply. And we'll let our capacitor bank charge up real quick. Alright, you can see we're all charged up. There's 2,000 volts. Let's see what happens. And let's try reading a dead short. See, it's reading 0.017 ohms or so. Let's go ahead and charge it up again. So you can see we're at 2,000 volts. And it's gone ahead and discharged it. Let's try reading our short again. And you can see it's reading a negative 0.105 ohms. And let's just try it with our 10 mega ohm resistor. We had like 8 mega ohms or something. Oh, interesting. Let's try it with 100 ohms. Ah. Well, that's interesting. 0.105 ohms. Let's try it with our 0.5 ohm resistor. Let's try it with a 1K. Yeah, we've definitely done more damage to this meter. There it is with a 10K. You can see it's having trouble ranging. Again, This meter was already damaged before I run this test. I'm not going to run this test on the good meter again. I kept that meter aside without ever transient testing it in case I needed it for a comparable. I don't have a lot of confidence that that particular meter would survive this test anyway, so I'm not going to go ahead and run that test. Again, the whole idea here is I'm trying to look at meters that would actually survive on this transient generator. What my claim is if they survive this, they would probably survive discharging the microwave oven capacitor. And that does seem to be the case. I don't have a lot of other meters left that we could run that would be a good example. I do have a few low-cost ones that I had purchased to run some tests on. Maybe we'll go ahead and include this as part of the evaluation of those meters. Again, I'm not a big fan of these meters that you have to treat like a little princess on a pedestal. This meter, again, very expensive, damaged it. There was no way to really repair it. Again, for the cost, I would rather have something a lot more robust. This BM869s has also gone through the 50,000 cycle life test, and it's been exposed to transients that far exceed this Keysight meter, and you can see it's still functional today. Again, I'm not an electrician, and I don't work with anything that's high power electrical outside of maybe these transient tests. As far as safety is concerned, it's not really an issue for me, but I am interested in having meters that are robust enough that can survive some basic transients that they may be exposed to in my lab. While I'm not suggesting you should ever take a meter, even like this Brymen here, and use it to discharge your microwave oven capacitors like this, I know that things happen in the lab. It's nice to have some confidence in your tools where they're not going to be destroyed if you make a simple mistake. Well, I think that's going to be it for this video. Hope you enjoyed it. Maybe you learned something from it. Again, happy holidays and Merry Christmas to everyone. We'll see you later.